Thank you very much. Okay. Yeah. Good morning, everyone, and thanks for coming to my talk. Today I'll talk about flexible authorization for Keycloak and policy agent, and we'll show how you use that and some use cases that can solve that. Yeah, my name is Thomas, and I currently work as a principal at codecentric, and I'm a huge open source enthusiast. I've been myself a Keycloak contributor for over 9 years. Like many of us here, I started open Keycloak in 2015 or so, and somehow never got away from it. And yeah, in the past recent years, I even was nominated to be the first official actor maintainer outside that for Keycloak, and I'm very honored by this, and I share that honor with a few awesome fellows from all around the world. And yeah, we all try to make Keycloak better for us and you all, and I hope we can continue to do so for a long time. And to summarize it, yeah, I just learned a lot from Keycloak, like near you as well. And before we start, I want to give a quick shout out again to the organizers of the event, like Sebastian and Niko. Thank you very much for setting up this event and putting up this awesome space together. Without you, it'd be possible to do that. And yeah, all the things to do organized. Thank you for supporting us here. It will be a great day for all, I guess. And yeah, I hope you have a lot of fun. So with that, let's get started. Since we are probably all using Keycloak for quite a while already, we know that Keycloak support use
like authentication and authorization
very well to some degree. And if we think about authentication, we don't care about, we want to identify who the user is. Like, we want to determine the identity of the user. Right? This is something that Keycloak can do very well. It's very flexible in that regard. And we use it every day in almost every project that we have. On the other hand, Keycloak also has support use of authorization. Like, we want to determine what the user is allowed to do. And here we want to see what kind of entitlements the user has, like rights or permissions the user has for certain application or resources and so on. But we all want to know how access control plays. All these use cases are quite often represented on common place applications everywhere. But as we will see, Keycloak currently doesn't support that use case in space of authorization very well. So let's take a look at what authorization Keycloak currently supports. For one, we have the REM side of things. We have this rel management support. We have certain roles in the rel management kind for Keycloak that give us some kind of core control over what a user can do within a realm. Yeah? The user can manage other users or create clients as create groups as well. But sometimes those grains are not fine-grained enough. And for that, we have this fine-grained admin permission that gives us more fine-grained control over realm resources. We can, for instance, which user can edit a certain group or which the authorization services that Keycloak provides. The authorization service, on the other hand, are a complete separate subsystem within Keycloak itself that enables us to write flexible access control policies. Yeah? There are a lot of built-in components, built-in rules that we can use. We can also use JavaScript to customize it, or we can even write custom policy enforcers of rules, so to speak, via the SPI that's provided, and so on. Also, if that what Keycloak provides to you is not enough, you can of course always write your own custom extensions, like custom authenticators, custom required actions to do certain access checks and so on. Yeah? By the way, you have some configurability in Keycloak already also, if you use the JavaScript support that Keycloak provides, where you can have basically, without writing your own extension in Java, you can also do things like restrict access to certain clients with JavaScript. Yeah? And of course, there are some community extensions available that helps you in that regard. Like if you want to restrict access to a certain client, you can use the restrict client auth extension, community extension provided by or built by Sven Torben over there. That is really flexible and gives you already almost for 80% of the use cases everything you need. Yeah. So, and what are the supported access control mechanisms that we have in Keycloak? Well, of course, we have this classical role-based access control model, where we can check whether a user has a certain role or whether it's being a client role or realm role and so on. Or we can leverage attributes-based access control, where we can check for a concrete attribute on a user, like allow access only for users that have an attribute called plan with the value premium and so on. We can also limit access with the authorization services, for instance, to particular users directly, like only allow users like Alex, Cindy, and Bert to access certain applications. We also have some support for context-based access control, where we can say, okay, access is only allowed to a certain resource during work week from 9 to 5. Or we can restrict access to only be allowed from a certain network and so on. Yeah? And this all can then be combined by leveraging a feature called policy-based access control, where we basically can create aggregate rules based or aggregate policies based on those building blocks above that enables us to write complex rules that can be applied in all sorts of different contexts. And even if that is not enough, what you have here, you can extend your own mechanisms via the SPI. So, before I show you how an alternative could look like, we first have to look at some basic infrastructure for policy-based access control mechanisms or components. And here I have a small example of an application where a user wants to access data, certain data in the application, and every access or every data request goes through a component which is called a PEP. A PEP is a so-called policy enforcement point, which is basically a component that intercepts requests and creates some kind of an access query for that. Yeah? The access query basically contains usually the identity, the operation that the user wants to perform, and the resource, the target of the operation. All this is then sent to another component called a PDP, which is a policy decision point, which is effectively a component that contains some logic in the form of policies, like a set of rules maybe, that is responsible for deciding, based upon the data from the access query request and maybe some additional data, whether an access should be allowed or not. These policies are usually managed through a policy administration point, like a component that manages policies, like has some kind of a versioning concept and so on around it maybe, and so on, that can provide policy data to the policy decision point. And sometimes the policy decision point cannot work on its own. Maybe the data from the request and from the policy is just not enough. Maybe it needs some retrieve some additional data information from other resources. And for that, we have the policy information point that gives us basically stuff like additional role mappings, role hierarchy information, permission to role mappings, or other organizational information. Yeah? All this information combined, the policy decision point can eventually make the access decision and return an access response or policy response back to the policy enforcement point, whose responsibility it is now to enforce that decision, like to allow or deny the request. Yeah? And that's basically what you find in every application, more or less, that has some sort of authorization in place. Sometimes it's all in one component or distributed system components, whatever. But these building blocks you can usually always identify in the system somewhere. Yeah? Like when Spring Security, you have these components in place, even if they are not named that way, but they are actually working with that responsibility. So, how does that look in Keycloak? the simplified diagram. So here, for instance, a user wants to access a resource through an admin, Keycloak admin endpoints and something like that. And Keycloak, especially if you use the fine-grained permissions, the endpoints effectively serve as the PEP, the policy enforcement point. That's where it's basically checked and enforced. And the access query is basically then performed against the authorization services, which acts as the PDP in Keycloak. And all the other stuff, like the policies that are defined, are then provided through the realm management infrastructure, which serves as the policy administration point. And on the other hand, we have the realm model, which then serves as the policy information point, like the data you work on to decide upon whether access is allowed or not. Yeah? That's what we basically have currently. However, I don't know, everyone who has worked with the authorization services already knows that it's not all shiny and rainbows there. Yeah? Because there are some severe limitations. For instance, you can only use the authorization services, or at least currently, for confidential clients. So if you want to restrict access to public clients or something like that, it's currently not so easy because you cannot enable it on those clients. Also, you have to use it in some use cases, like if you want to use fine-grained admin permissions. As I said, you need to configure all sorts of infrastructure with the authorization services there, which is not fun, especially in larger environments. Also, if you want to use advanced OAuth features like OAuth token exchange, also you need to create a client policy that enables that token exchange. And just in order to enable this small functionality, you have to deal with another subsystem again. Yeah. Yeah. Also, as I said, there is currently no built-in support for restricting access to a client. You can create policies that restrict access to certain client applications, but you cannot enforce it in Keycloak at the moment, yeah? Directly. And that's where you need either custom extensions or you need to use community extensions or the JavaScript support, for instance. Yeah. And in practice, I've learned in over 200 customer projects over the last 5 years, it's quite difficult to use, actually, and very hard to maintain if you have a large policy base or a large infrastructure that you need to cover. And yeah, also, it's difficult to manage via configuration as code tools, right? Because it uses its own endpoints to manage the configuration. And yeah, you need to you have a configuration as code tooling that supports those endpoints, which not every tool can. And if that is the case, you need to resort or fall back to your own script-based policy update mechanisms and so on. Yeah. So, to me, it seems that, at least at the moment, authorization is currently not treated as a first-class citizen in Keycloak at the moment. And I'd like to change that. And I hope you agree that this is a good idea. Let's see. How could an alternative or an enhancement, at least, to authorization services look like? Let's recap, or let's just define some requirements. So what do we want, or what would be nice? It would be nice if we could define policies just via code. No UI clickery involved. We could just write code that can be easily checked and verified. We want to easily validate and test our policies, maybe potentially even without touching Keycloak. Yeah? We also want to be able to change policies easily and maybe apply a GitOps-like approach, because we can treat it as code. We can deploy a GitOps-like process to roll out new policies that gets then applied automatically over time. Also, we want to be able to trace and follow policy decisions to see why a certain access request was denied at some point. Yeah? And the question is there a way to achieve that? Well, maybe there is. So for that, let me introduce the Open Policy Agent. Question here, who of you already have used Open Policy Agent in a project? Okay, just a few of you. That's good. So, what is Open Policy Agent? Open Policy Agent is basically an open source policy engine written in Go. It's basically a dedicated server, so to speak, that enables you to evaluate policies, validate policies, and can support a push or pull model for policy distribution. Yeah? It's basically developed by a company called Styra Inc. and has been and a lot of community developers involved. I think it's a CNCF project for quite a while now, and it's used all over the place in the CNCF ecosystem. Like mostly for some use cases include microservice authorization or infrastructure. In infrastructure as code scenarios, like admission controller for Kubernetes to see whether a certain deployment can be rolled out or not, and so on. And there are many, many other use cases, just to mention a few. Their main mantra is, let us treat policies as code. So if we can treat policy or authorization logic as source code, we can use all the things that we are used to have with regular source code. Like we can version it, we can lint it, we can test it, we can refactor it, we can audit it, and we can run it. Yeah, and that's something that's really cool to have because it gives you improves the round trip, reduces round trip times, and makes it easier to test and roll out new things. In order to do that, Open Policy Agent supports a declarative policy language called Rego that we will see in a bit. There are some deployment options for Open Policy Agent. First, of course, if you are a Go project, you can wrap it, use it as a Go library, but mostly you would use it as a sidecar, deployed as a sidecar alongside your Keycloak container and so on. And with that, you are completely, can then configure Keycloak in such a way to speak with Open Policy Agent and a sidecar in a matter that does not have that much latency, because usually you apply this sidecar in a co-located deployment, or as a co-located deployment. That means the requests are usually taking just a few milliseconds between the systems, between the containers and so on. Yeah? Okay, how does this now work? We have, usually it looks like that. We have our service and we have some kind of request or event or whatever that triggers some logic in the service, in the application. The service has a component then that creates an access query or policy query based on the request and sends that access query to the OPA sidecar. The access query can be an arbitrary JSON object, so you're completely free to use whatever you want here. The OPA sidecar itself has the policy, like the rules in Rego in memory, combined with some maybe additional data, like as said, additional role hierarchies or role to permission mappings or other application-specific data and whatnot. Yeah? All this data combined, like the query, the policy, and data, will then be used to conclude an access decision, and then you will return the decision, the outcome, as a JSON object, again, back to your application, which is then responsible to enforce that decision. That's basically how it goes. And now imagine, instead of a service, we use Keycloak instead. Keycloak is, in this case, our application for certain cases. But let's first look at Rego as a policy language, just that you get an idea how this would look like. As said, Rego is a declarative domain-specific language that is inspired by other languages like Datalog and Prolog, like logic programming language. And it basically consists of a few building blocks, which are policies, which is effectively a collection of rules. A rule is basically a named collection of conditions that are combined via AND. That will get to us in a minute. These conditions can be Boolean expressions or calculations of some sort that somehow result in a Boolean result. And you need to know that there are two implicit variables for us. There's this input variable that refers to the object that was given to you in the policy query. And there is this data reference to access data that is either provided to OPA or fetched from somewhere else, or some other modules that you can see. OPA has built in many functions that you can use to solve all sorts of different problems. Like you can, for instance, decode or validate a JSON Web Token. You can parse JSON. You can even do things like checking whether an IP address is within a certain CIDR network range, and so on. Yeah. And just to give you an idea how such a policy file could look like, it's basically just like that. We have a small text file. We have a package concept, so you can hierarchically organize your policies. And here you see two rules, effectively. Here we have a rule with the name allow that defaults to false. So by default, we want to reject all requests if they are not matched otherwise. And in the second instance of that rule, with the same name, we say that, okay, but if the input method is get and the input path is public, then please, if this is the case, allow requests in that regard. Yeah? So these are the conditions that we have here. And one important thing to know about Rego is that, or OPA is that it tries to match the most specific rule based on the given input. This rule is then effectively selected to perform to conclude the result of the rule. So we will see that in action in a second. How do we select open policies? First, since we use an URL to identify the actual policy, we have a component that basically selects the policy that in the hierarchy that we provide, and we can also provide the rule in the policy that we would want to select via the URL request path. And as you can imagine, you can either refer to a policy as a whole and execute all the rules that are contained there, or ask for a specific thing. If you are just interested in whether we can access certain data, then maybe the access rule is sufficient. Okay, policy input, as said, can be any arbitrary JSON object as long as it is wrapped in a JSON object that has an input attribute. And this is usually consisting of identity information or data from the application or the request. And to execute a policy query, you would basically call a gRPC or REST API interface. Like in this case, we would send a post request to a certain path, let's say, that selects an access policy in our case. And here we want to check for the rule allow. And as an input, we send the current subject, the current action, the current resource, like which client we want to access, and the context information, like which IP address we currently use and whatever. Yeah? That stuff. And here's a small example how that looks. Here's a small OPA policy in Rego. And here I want to access, for instance, or here I have rules defined that says, okay, allow is by default false. So everything that's not explicitly defined here gets denied by default. And I have two rules here. If the request comes in with get and to/public, I want to allow public requests. But if requests to/admin are sent, then I need to check whether the current user has the admin role. Yeah? And for instance, if I check query here internal data, you see allow is false, so access would not be allowed to any unlisted path. And if I access public information, I can do so. By the way, if you want to see which rules actually were used, you can use this Open Rego playground here provided by Open Policy Agent project. And if you click on evaluate, you get actually you get a list of the rules that are effectively touched by the query. And if I now try to do an admin request, you see that, now this rule is triggered, but it failed with this predicate. So the isAdmin was not satisfied, and therefore it resulted to false. Yeah. If I now say that, okay, maybe I add the admin role to my token, to my access token, or configure admin access in the application, and if I try it again, you see, suddenly allow is true, and now I can access my resource. Yeah? That's basically how it works. So, in fact, it's quite simple once you get around how the language works. So, with that said, how can Open Policy Agent work with Keycloak? Well, the idea is to use Keycloak as policy enforcement point and OPA as the PDP instead of authorization services. And in this case, we use Rego to define policies in Keycloak. And by the way, with this approach, this is not just limited to access control logic, because some use cases that could be enabled are fine-grained admin permissions could be replaced with that. So I could have basically a policy that says, okay, when this group, when the user wants to manage this group or edit this group, he or she has to have this role or be member of the other group. Yeah, just as a text defined. I can also allow or reject identity brokering processes. I can also use OPA policies to configure which kinds of claims or assertions are exposed as OIDC or SAML artifacts. Yeah? And of course, I can use it to manage access for custom endpoints that I put into Keycloak. And of course, and that's the use case I will show here in the demo, I can use it to limit access to certain clients. Yeah? So what are some integration options that we have here? Of course, we could leverage an authenticator, the authenticator SPI, or we could write a required action, client policy, protocol map. We have many, many options. Or we can even extend existing community extensions like the restrict client auth extension and so on. But let's see. Yeah. So in the following, I have basically set up the following thing. I have a user in the realm called OPA demo, and Keycloak is configured with an OPA extension that can then perform access queries against OPA as a PDP and evaluate those access. And it works like that. Imagine we want to access a certain client. In order to do so, we would basically evaluate a policy that we can find based on the realm name, based on some scheme like Keycloak, realms, and OPA demo. And we want to evaluate the access policy and want to check whether the rule allow evaluates to true. Yeah? That's basically what we have. And an access policy could look like that. Yeah? We could say that allow if the Keycloak client is app and the client has current client role access. That's all. Yeah? You see here this KC utils thing. That's basically a helper structure that gives us some kind of a DSL to easily specify some kind of functions that we can leverage here. Yeah? So, and how does it now work? So if a user now tries to access a certain client like the app here, we generate this input query. Like we say, okay, input is the following. We have a subject with the following ID, the following username with realm roles, client roles, attributes, and so on. This subject wants to access this resource with this client ID and in this realm maybe. And the context is he or she uses the following protocol, the following remote address, and is from a staging system or a prod system, whatever. Yeah? And all this is then fed into the OPA policy. And as a result, we get back the access decision, like whether the access is allowed or not, and we get some metadata alongside with it, like the generated decision ID that recorded this interaction and can be used to basically trace back the interaction for later use. Okay, and with that said, now it's time for a demo. Here I have a Keycloak environment running with 3 users, test, guest, and admin. And I have a few roles like user, guest, and admin again, a few groups, and so on. Yeah, and I have clients that show me some use cases. So, and as a start, maybe I want to restrict access to the account console to users that have a certain role. Like, for instance, if I use it now, let's see. If I access the client application, you see it worked. And if I look at the log, you see there was no it's already configured. You see, the following access query was sent, yeah, from the extension that I configured. So the client, in this case, the user tester, wanted to access the account console through OpenID Connect, and the access was granted because the user had the following role. Because if we look at the policy that is associated with that, we will see the following. Yeah, I see here I say, okay, I have a default role allow false. So by default, if the client is not explicitly listed there, I want to deny access. And here I just say, okay, if the client is account console, then the user has to have the realm role user. Only then the access is allowed. If I change that somehow, like use a role that doesn't exist, and if I try try to access it again, you will see access denied because the requested role was not found. Yeah. So, and by the way, you saw I just edited the policy and it was live immediately. Why is that? Because in this example, I start Open Policy Agent as a sidecar container here and just basically watch the policy files that are listed on the file system. But that's just one way to do it for local testing. You can also configure Open Policy Agent to fetch these policy files from a URL or from a tar file that you provide, or from some container format that you deploy in your Docker registry. Yeah? There are many ways to transfer this kind of policies. And yeah, and if we look at some other use cases here, what do we have? Just to give you an idea how an access policy could look like. So this is an access policy for a client. This is an access policy for app 1 that says, yeah, if the client is app 1, then we require the client role for app 1 to be accessed. Yeah? Or to simplify the previous use case a bit, we can have an access policy for app 2 that says, okay, we want to require the current client, the role, we want to require the user to have the access role for the current client, which is app 2 in this case, yeah, and so on. And the same goes for checking whether a user is a member of a group, and so on, yeah. So, but now comes a tricky bit, because I said that initially these rules that Rego specifies here are combined via AND, yeah. So this checks whether the client is app 3 and the user is member of group users. Yeah? But what if I have a more complex scenario where I want to use OR? Yeah? And funny thing is, this language does not have an OR as a predicate, as a operator, so to speak. But you can do something similar. You can say that, for instance, here I have here this helper function special client, which checks whether the current client the user is requesting access to is a special client, and then I want to have the foo bar group. And this is basically done by defining this function twice, this helper function here. And in the first time I check whether it ends with foo, and the second time I check whether it ends with bar. And Rego will basically evaluate both rules and try to satisfy both rules. And the one that matches is then enough, let's say, to make the rule pass. Yeah? That's how you implement OR. Another way to implement OR is by using set operations. Like, for instance, if I want to check whether a client is the account client, either being at the old account backend or the account console. Yeah? And that's I can just do with this helper function, and this serves the same purpose. Yeah? So far, so good. You might wonder, okay, that looks nice and easy. How complicated do the helper functions look? Well, that's it. Yeah? The helper functions are mostly one-liners that check for one specific value in the input most of the time, or do some kind of string concatenation and then membership checks and so on. What is also possible is to leverage the built-in functionality of Rego, for instance, to use functions like checking for network and so on. Like here, I have this helper function is from network, and I check whether the current IP address belongs to a certain CIDR range. Yeah. And the helper functions for that is also just a one-liner, but uses the built-in net CIDR support by OPA and so on. Yeah, and you see, you can be pretty expressive already with very concise code without writing any additional infrastructure at all here, if you have that in place. Yeah. So now you might wonder, how is this done? How is the access check performed? Well, of course, the obvious answer here could be to just use a custom authentication flow, yeah, that basically wraps all the authentication executors or the components in a separate subflow, so to speak, and then run the OPA authenticator as a required flow afterwards. So that's the most straightforward solution. However, yeah, it's quite cumbersome to have to remodel the authentication flow, even because most of the time in practice they are already quite complex if you have some customizations in place, and maybe there are some other means to do it. And what I did instead here was to use just a required action that I can basically run after each browser flow. Yeah? So regardless how the user logged in, whether it was a fresh login, whether it was a cookie-based login, whether it was an identity brokered login, whatever, or whether it came in with Kerberos, OpenID Connect, or SAML, doesn't care. This get always executed, and with that I can guarantee that access checks are performed properly. Yeah? With a caveat. Problem is, these required actions are currently only executed for the browser flow and for the direct grant flow for some reason, but not for client's flow. Yeah. Another question is how when I want to restrict usage of grant type password like direct access grants or client credentials grant, how can I do that if I cannot adjust the flow in a way? Because maybe some of you don't know, you cannot create, or currently you cannot create subflows for the client flow here. Yeah, but that's exactly what I would need. I would need to wrap all these alternative flows in a subflow that I can add my OPA access check flow authenticator afterwards. But this is not possible currently. Yeah, for some reason. I haven't looked into the details yet, but it's not possible. So are we stuck now? Well, not quite, because there is this support for client policies in Keycloak, which has been added a few years ago, or starting a few years ago, let's say, and is actually intended to implement some kind of security profiles for Keycloak, like support for the FAPI, financial grade API stuff, and so on. But you can also leverage that to create your own additional logic that is executed whenever a client interaction happens. So in this case here, I created a custom client profile, which I call OPA access profile. Yeah? And in this access profile, I have a custom component configured, which is called OPA client access policy enforcer. And in this, here I have I configured basically the URL where Keycloak can find Open Policy Agent, and I configured here a template for a policy path that can be used to perform access decisions. Yeah. And here I have some additional configuration, like I don't know which attributes should be passed along the permission the access request, which context attributes should be extracted, and so on. And I can also say that, okay, please forward some realm attributes, please forward some specific client attributes, or some specific request headers. All this data can then be added to the policy query, and with that I can then basically evaluate my policies. So, and with that profile in place, I need to activate the profile. How to do that? Well, for that, we have the policies as an additional step. And here I created an OPA client access policy, which says that, okay, for any client, please apply my check access profile. Yeah? And this basically triggers the execution for the policy evaluation as well. And now, if I try some HTTP request here with grant type password or grant type client credentials, you will see, click, you will see that the policies are in fact evaluated and queried. And here we see, aha, the grant type password was used with the client that configured direct access grant in this case. And the same happens if I do a client credentials grant. Yeah? Here you see grant type client credentials with my client credentials client. Yeah? And with that, I can basically restrict all client interactions possible with Keycloak and pass them through a policy governed by Open Policy Agent, where I have then now a uniform way to restrict access in certain contexts for certain clients, which is quite nice. So, yeah, that was what I wanted to show in the demo real quick. But there's more. So to summarize, the access request would look like that. And of course, we would get a corresponding access response that we can then evaluate in our system. And the building blocks that I used was just a required action, because it's more universal in that case than just an authenticator, which I would need to configure at multiple places maybe, or at least with multiple flows. Then I configured this client profile and client policy with the appropriate configuration and so on. Yeah? But there is more. How cool is that? You can even test your policies without running Keycloak. So you can write tests for your policies, like I have here. Here you see I have the policies configured, yeah? And here in a parallel package, I have a policy test, yeah? For the access policy. And then I can run a tool on the console to quickly run the tests and check whether the policies basically evaluate to true in this case for the given input that I expect, yeah? And all that without running Keycloak. That's cool. And this also allows users maybe to edit their policies and test them in a separate application outside of Keycloak, yeah, without having to recompile anything. Yeah? Okay. And yeah, of course, there's some additional tooling that you can apply here, like there's a linter for Rego that gives you that checks your code for idiomatic language usage. And of course, there's also a mechanism to transfer policies with data in a package format, let's say, that can be deployed via Docker registries. So if you already have a Docker registry in your infrastructure, you can basically deploy a open policy container fragment there and pull that from any OPA instance, and yeah, periodically fetch it and check for updates and so on. Yeah? Okay. With that said, I want to summarize authorization services in Keycloak. Although I have not shown them, but I'm sure if you have used them, you understand what I mean. It's practical for some use cases and even required, but it definitely needs better developer experience. There is some support for restricting client access, which is an often requested feature. I mean, almost all of my customers ask me that at some point. Yeah? And as said, currently it's possible via the JavaScript authenticator or via the community extensions. And actually, what Keycloak currently is lacking is some notion of an access policy feature, right? Where I can define under which circumstances can a user access a client without using authorization services, without using maybe any other additional system even. Yeah? But that's something for the future. The combination of Keycloak and Open Policy Agent, as I've probably shown you, enables flexible policy management because decisions can now be delegated to OPA and enforced by Keycloak. And we can now leverage all the stuff that is available in the OPA ecosystem, which is quite a bunch. And yeah, it also can help to consolidate existing access logic, especially if you already are using OPA maybe in your application or for other parts, you can share access information like when a user can actually use a certain application and maybe move the check forward or and so on. And the question I always get asked is, oh, well, does this replace access checks in the application itself? And then I would answer, no, of course, but it gives you another option to even check access earlier in the workflow, and this enables sometimes new use cases. For instance, you could detect that during login, the user is lacking a certain role for a certain application. Yeah? You can detect that in Keycloak. And then, instead of just displaying the access denied page, you can basically show a page like, okay, sorry, you cannot access this application, but click here to request access to the application. And then you could basically create an access request email or something like that gets sent to the manager of the user or the person responsible for the client. And then the client can maybe allow or reject that request and send the user an email that says, okay, now your access is granted, please try again. Yeah? Just because Keycloak knows that the access is allowed or not. Yeah? And something like that. So, and with that, I want to say thank you very much. Now it's time for questions. Code and slide you find on my GitHub. And yeah, looking forward to your questions, and thank you very much for your patience.
Any questions from the audience?
Hi, thanks for the presentation. Close. Oh, yes.
Oh, yeah.
I have some question regarding the order of the evaluation of this policy, because I was thinking of use cases where you want to enforce policies before the user authenticated and maybe after he authenticated, just to see which role he has. You have to know the user, so he has to log in to be logged in, but sometimes you want to evaluate some policies beforehand. Is that possible as well?
Yeah, this is possible with the authenticator approach. I mean, you can place an authenticator in at the very top of the authentication flow in this case, but that comes then with the limitations that I mentioned before, that you would need to add this authenticator to all the flows that you require, and sometimes it's not possible. And but generally it's possible to add additional logic there. But I used the required action approach to capture, let's say, the last moment before the application the user leaves from Keycloak to the application. And that works quite well in practice, so to speak. Thank you.
Very nice. We also played around with OPA a bit with Keycloak, and my question was, can you teach OPA also to not only give like this allow true false back, but also, for example, if I wanted to enrich my token with some sort of policy?
Okay, that's a demo for later or for the afternoon. But I mean, I simplified this quite a bit. If you go more fancy with this, you can basically return here an arbitrary JSON object, like a data structure. And you can say, in the data structure, you can have the information like access allowed, yes or no, true or false, and additional information like which role was actually missing, and so on, and or maybe a custom error message, and so on, That's all possible, but let's say, for the sake of the example, I kept it per minimum, but it's possible, Okay.
So, my question is a little different. We have planned a very similar architecture, just not with Keycloak as the PEP, but as the PAP-PRP. So basically offering the policies. Did you also think about that yet? And did you start with that maybe already?
Yes and no. Yes, I thought about that and played a bit with that around. I mean, that's obvious, right? You could always have have the policy. Have a custom policy enforcer implementation as part of the authorization services, and maybe generate even policies from the data that you have there. But as said, my initial point was that it's quite complicated to use the authorization service as it is now, especially if you have large deployments with many clients and many different access rules, and it gets let's say, crowded quite quickly, and it's hard to keep an overview. Therefore, I basically decided to move away from that approach and just use a plain single code-based file, right? That defines the X policy for the whole realm. But of course, this can be extended to, okay, I could have also multiple files here for per client, for instance. A file per client with a client policy that only contains maybe this, and maybe some of the additional plumbing like this. Package stuff that Rego provides supports, but and for me, an approach with code policy as code only works better in practice and scales better over time, I think. But I mean, you can build a UI on top of that generates that files, of course. That's always possible, right?
Let the Gen AI do the job.
Okay. Any more questions?
I'm sorry, we need to cut the questions here. Thank you all for the questions. We have Thomas for sure for the rest of the day, so just ask him. And we have this open space in the afternoon. So.